Hey everybody, this is the second video that I'm making in a series on Introduction to Limits. And what we saw in the first video as a quick recap was to see how we use general notation in pre-cal to read a graph to see as x does something, what does y do? And we talked about the vocabulary of a right-hand limit, a left-hand limit, and a general limit and the notation that we used for it. And we can kind of see the notation being applied here. This would be a right-hand limit as x approached 4 from the right-hand side of function f. And all we're going to be looking at here is now, can we take those function notations or the limit notations, I should say rather, for what we're talking about from our previous video and see, can we apply them to this piecewise function and see how are they going to interact with each other. Now I have this again graph just kind of floating around here. You can kind of, I'm going to try and move it out of the way a little bit. And before I get into it, I just want you guys to go ahead and try practicing a couple. I'm going to go ahead and I'll go ahead and get you started just to get your feet wet a little bit. Let's take a look at some of the values on the left column. So part A, f of 2, is simply saying as x approaches, I'm sorry, not approaches, but when x is 2, what is y? And looking at the graph, when x is 2, you can see that we have something where we have it's not included here, but it is included here. So when x is a positive 2, y is going to be a negative 1. And that's what I would have here in my solution. Now we're looking at the left-hand and right-hand limit notations. So the next one, part C, I'm just kind of going down. We're saying the limit of function f as it approaches 4 from the left-hand side. So as I approach 4 from the left-hand side, I'm kind of traveling up this piece here. And when I get to 4, there's my point, and the corresponding y value is here to 3. And so that's what I would put here in my solution, is I would say that this is going to be approaching 3. And we'll just do one more before I pause and let you guys try to finish out the rest of these. Let's just do E, the limit of 2, or the limit of f as x approaches 2 from the left-hand side. So as I'm approaching a positive 2 from the left-hand side, I'm kind of on this downward curve of the parabola. And when I get to the 2 from the left-hand side, I'm stopping here, and I'm just looking to see what's the corresponding y value there, which in this case is a negative 1. There we go. So at this point, go ahead and look at the graph that you have in your notes and finish filling in the rest of this table using the limit notation. And when you're done, go ahead and hit play and then check how your answers look with the rest of mine. All right, so hopefully you've had an opportunity to fill in the rest of the chart here. I'm going to just move the graph kind of out of the way so we can finish filling this stuff in. All right, so moving down the first column here, let's go ahead and look at G. Oops, I didn't mean to have my annotation turned on. So here G, the function is going to approach 2 as x approaches negative 1 from the left-hand side. Here, this one caused a little bit of confusion in the class, and the fact that why does the limit not exist here? Well, if you look at the function, it's asking you to see, well, as you approach x, or as you approach negative 4 from the left-hand side, you're supposed to be coming from over here. Well, there is nothing over there. The function is having a restricted domain from starting at negative 4, so you can't have anything to the left of negative 4. So for that reason, there's a limit does not exist here. And K was probably the most confusing one for some students in class, particularly if you looked at the right-hand column first. Here, we're saying the limit of function f as x approaches 2. Well, if I approach a positive 2 from the left-hand side, I come here and I would get a negative 1. But if I approach the 2 from the right-hand side, I'm coming down here and I approach a positive 1. Because the two different sides of the limit approach different numbers, a -1 and a positive 1 respectively, they cannot approach the same number to give me a limit. So this one also has no limit. It does not exist because the function is really discontinuous at that point. So it's called a jump discontinuity. Here, part M, we get a -1. And I'm going to just open up the rest of these here and just, you can check yourselves. If you have any questions, let me know. And most kids in classes do okay on that right-hand side. It's really K is the one that kind of throws people off the most. All right. So that's how we use the limit notation to look at a graph and interpret it and see what we have. Now here, this is not the greatest thing in our notes, but it is something that it's trying to give you a different way of identifying what you're looking at. It's giving you an analogy of, like, if that graph was a road, how could you describe the graph at those points? So they're saying if we think of the function as a highway, then at point 2, -1, you can consider it the end of the road. While at -1 and 2, it's kind of like a pothole. So keeping in with that analogy of we're talking about being on a road, at 2 and 1, I would say it's a dead end, and at 4 or 3, I would say it's just a bump in the road. So now that we've talked about how you can use limit notation, let's talk about when limits will not exist. And actually, I'm going to go ahead and pause this for here because we're already at about 7 minutes, so I'll continue this one in a third video. So keep in mind how we read the graph using our function notation or our limit notation, and if you have any questions about anything, guys, by all means let me know. I'll be happy to work with you. But until later, thanks for watching and take care.